Okay, so this is a little different talk from what I normally give. Normally I try to be fairly technical. This is going to be more of an experience report of what it was like at a company I co-founded, Operable. We built a product that was Chatops automation, and we built it entirely pretty much on top of the Erlang VM using Elixir and a little smattering of Go. So I'm just going to share like some of the experiences we had building this and kind of what it was like, why we chose Erlang and Elixir. I had originally planned on also having like a little demo, but the network gods are not kind at conferences, so that's not going to be possible. However, I do have part of a canned screencast, so we can at least see what this stuff looks like in action. So a little bit about myself. I've been using Erlang since around 2008 and Elixir since 2015. Somewhat controversial statement, I guess, is I really, really like Beam, the VM. Erlang is okay, but I really feel like Elixir is the language that the Beam deserves in a lot of ways. It's so, like I said, I've been doing Erlang for a long time. I've done Erlang training. At one point, I worked at Chef, where we built out a big engineering team around Erlang, and so I had to level up about 36 devs to get them used to writing Erlang. And that's all doable. Elixir is just that much easier because it looks a lot more like modern languages that folks have more experience with, like Python or Ruby. So I'll get that out of the way. And I've worked at a number of places where I have used Erlang mostly. So Engine Yard back in the day, Heroku, Chef, and more recently at Operable. So, how many people here know what Chatops is? A few people. All right, so I'm going to define it a little bit. In the short term, a great way to think about Chatops is that you're performing operational tasks in chat. So, if at work you use something like Slack or HipChat to communicate with the rest of your team, Chatops gives you the ability to perform a lot of like your day-to-day tasks you might do, like, say, managing CI or CD builds, checking monitoring metrics, provisioning new environments, paging people when shit goes sideways, just to be brutally honest. These are all things you can do with Chatops. Longer term, I think the vision is make chat act like a shared command line. And really, the way you want to think about it is a multi-user collaborative shell. And that's where we were trying to go. So this is a book that came out, I believe, last fall. It's written by a guy named Jason Han who works at VictorOps. It's a really great introduction and kind of summary of the current state of the world in Chatops. So if you're at all interested in this kind of thing and want to learn more, this is a great place to start, and it'll give you a lot of starting context. Another good place to look on YouTube, Jesse Newland, who is, I believe, the ops lead at GitHub, did a talk back in 2013 about Chatops, because GitHub is kind of what really started evangelizing and building a lot of interest in Chatops, and so that's worth a view as well. So, Chatops architecture today. Let's talk about that a little bit. So typically, hello. Is it lanyard off? Yeah. One moment, please. There, maybe we'll keep the annoying thumbs down to a minimum. Okay, so Chatops architecture today. Mother of God. How's that? Is that better? Is it me? Yeah? All right. All right, so Chatops architecture today as it stands. So really popular Chatops bots, for lack of a better term. The most popular one I think most people have heard of is Hubot. There's another one called Lita. Hubot's written entirely in CoffeeScript, so it runs on Node.js. Lita is written in, I believe, Ruby. They both have basically the same architecture. So you have this chat interface that's responsible for talking to whichever your chat provider is. It's got some core bot logic that's responsible for things like noticing when a user types a command. Wow. Noticing when a user types a command and doing something with it. And then it's got these other two components down here that are responsible for doing things like loading scripts when you add a new command to the system and actually executing the command. The drawback to this approach is that this is all in a single OS process. And so what we found was, while this is great for smaller teams at smaller companies where it's maybe like a total of six people on a team all working on one thing, if you need any kind of security guarantees about the system, the fact that you're loading basically arbitrary code into the same process that's responsible for enforcing, say, like system invariance, that's kind of problematic. And so, well, let's see. Yeah, and so one thing you see a lot, especially with Hubot, is folks have over time kind of invented and reinvented different firewall mechanisms for trying to control what like these scripts have access to, and how you access, adding concept of like ACLs, access control list, to control who can execute what script. Again, the problem with all this is that since all this is running in the same process in the same like JavaScript virtual machine, these scripts can just do an end run around the code. So not great. So we looked at this and said, can this be improved upon? And we said, well, what are the real requirements? So it needs to be reliable, because this is, with any luck, going to be a critical path tool for a team. You're asking folks to base their whole workflow around, your Chatops solution, whatever it is. So even if like you as an individual want to bring, say, like Hubot or Lita or what I'm talking about here, our platform called Cog, into your team, one thing you have to realize is what you're really asking folks to do is start relying on this. So like when stuff breaks and you've got to get up at 2 a.m. and fix it, if Chatops is how you're doing things, then the bot needs to be available and work. A lot of the time, these bots are going to have access to sensitive information in systems, and this is especially true for companies that are operating where they have to deal with things like credit card regulations about who can touch what data and what kind of audit logs you have to maintain, or healthcare companies that have to deal with like HIPAA requirements. So that's reliability. The bot also needs to be extensible. Because every team, every company has their own unique itches they want to scratch. And the bot is only as good as your ability to extend it. And so you might be wondering, all right, so you have a bot that's written in Erlang and Elixir, and you're going to ask folks to extend it? What were you thinking? But I'll get to that. We didn't ask them to write Elixir, although they could. You want to make it really easy to scratch new itches. You need to realize that even though they're, like in Hubot's case, there is an absolute ton of scripts already available, and they're easy to install and use, that generally they're always going to need to be customized, because what's right for one person's environment isn't going to be right for your environment necessarily. Even if you're like trying to administer, like you need to talk to Graphite and pull some graphs and put them in chat, the way you name things in Graphite isn't going to be the same as another company, so on and so on. There's also some challenges here. I mentioned security. You've got, again, the system, sensitive information and systems access. Larger teams are also going to want some sort of audit. These are things that the current crop of bots don't really do at all. They just kind of punt on this whole thing. So one example that came up at a conference I was at, I saw someone from GitHub presenting about Chatops, and someone in the audience said, so does this mean that anyone that can get into the chat room can talk to the bot? They're like, well, yeah. So anyone that can log into Slack for example, could reconfigure your border routers. Problem? Why would you not want that? You're also functioning most of the time in a dynamic, cloudy environment. So lots and lots of workloads run on AWS, and more people are running on things like CloudFormation and Kubernetes and Mesosphere. And so you need to be able to play well in those kinds of environments. And then finally, and this kind of gets into the extensibility thing, third-party API integrations. You need to be able to talk stuff like Datadog and Graphite and PagerDuty and Status Page I/O. I mean, there's just a plethora of APIs. And it seems like, there's so many APIs, and these companies will ship like client libraries, but they're written in any number of languages, right? So if you say, I'm going to write my bot in Ruby, you can almost guarantee that something you really want to use is only going to have like a Python client. At some point that happens. And so how do you deal with that? So we came, after we kind of did this little design exercise, we said, well, can we do better? And we said, well, what if we combined a robust, highly concurrent VM, not to name any names, with an accessible functional programming language, not to name any names. And this is what we came up with. So this was our cute little mascot cog. He was written in Elixir, and he was responsible for running all of the core logic of the bot. So enforcing access control and noticing like when you typed a command, that was all done here. These guys were separate processes, potentially even running on other machines, and all they were responsible for was executing commands. This was all really simple to implement because Erlang has baked in right into the core of the language in the VM this whole notion of message passing and distribution. So this was a really natural way for us to model the system. What's nice too about this is you notice that since these guys are outboard processes, potentially not even running on the same machine, you get away from the security problems you had initially with the other design where you're loading arbitrary code into the core of your application. So for commands that need to, like, say, access your customer database in production, knowing that any command that you install here can't really subvert your core logic, that's a nice reassurance to have. The other great thing about this approach is that you can have separate ones of these relay processes running that have access to a limited subset of your environment. So you never get into the situation where this guy has complete access to everything. So in a worst case, nobody ever wants this, but if you have a breach here, whatever they're able to compromise here doesn't necessarily mean that they can leapfrog somewhere else. So, going back over the requirements. Reliable. We have an actor shared nothing model. By default, this kind of allows us to be very concurrent. We were able to model the commands coming in to the bot as each got their own Erlang process, kind of very similar to how you might build a web app. So, it's very natural when you're doing web programming with Elixir or Erlang, each request is its own process. Same thing here. Beam VM, I need to say no more about that. Extensible. So Elixir and Docker for the win. And if I could do a demo, I would get more into how we integrated Docker into our stuff. But needless to say, what we did here is we took a page from Heroku's playbook, and rather than requiring that all the commands be written in Elixir, we allowed them to be written in any language you wanted. And the way that we executed them was to run them as a Docker image, so in a container, and set a bunch of environment variables, and then just tell the command to go. So we set environment variables that said, like, here's who the current user is, here's the arguments you were called with, now run. So it's basically kind of shelling out into Docker every time we ran a command. And this allowed us to say, write the command in whatever language you want. We really don't care. We just need it to be packaged as a Docker image. So I think I've already talked about that. We implemented ACLs, which I won't really get into today because I'm not up here to show about what we built. But we used leaks and Yek to build our own kind of custom ACL language. Really decent experience with that. And dynamic environment. We really embraced cloudy tools. So we shipped out of the box as Docker images, and we built everything so they could be run as in a CloudFormation template. And as I was saying earlier, with the chat commands, we also kind of wound up using Docker as a package manager, which sounds kind of weird when I say it out loud, but it worked really, really well. And as I've said, like at other talks I've done, Docker's real innovation is not like containers. What their real innovation is the image, and the whole idea that the Docker image is basically an executable package that comes like all together with everything it needs. So if you're distributing software, this is a really great model to use. And we got to the point where really the only thing we shipped was sets of images. We didn't build like Erlang releases and ship those as debs and RPMs and whatnot. We just built images and shipped those because that's what our users wanted. So third-party integrations, I think I already touched on this. Yep. So before I kind of show what this looked like in action, I want to, if you'll indulge me, a small mini rant. Syntax matters, and it matters a lot. So this is something I ripped from, there was a group at HP Enterprise, I think they were spun out, that was really pushing Chatops at one point. And this is how they built their commands. This is fairly indicative right now of the current state of Chatops. I kind of call this pigeon English. I guess it's nice to read. It seems like that would be hell to type. Because in chat, you don't have autocomplete anywhere. So yeah, if you wanted to, whatever this thing does, if you wanted to run this BPM process of whatever, you've got to type in all of this. So imagine this is like something related to what you do every day, and your phone is going off at 2 a.m., and you're going to type something like this in. Like, this just seems like a nightmare. If only this was a solved problem, and it makes me a little sad that more people don't think of this. So Unix, piping commands since 1973. I don't know why this hasn't kind of become more of a thing. If you look at like one of these invocations, here's the stuff you really care about, like you're invoking some BPM process for this app from some other thing, blah, 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 blah. You've got like a host and a location and an instance, right? So there's like a total of 21 words here, and like well over half of them are just connector words that don't really add much. They make it nice to read, kind of like English. So if instead you make it look a little bit more like a Unix command, and so you see there's this pipe operator here. So I'm taking the output of one command and piping it into the next, like you would in a regular command line. And I'm using arguments and options. I don't know, to me, and maybe I'm kind of old school and crusty, this to me seems a little bit more readable and more like what I would expect. So this is shorter, less words, no connector words. And maybe this is a little hyperbolic, but I don't know, this to me seems to be a lot more concise and understandable. Kind of gets right to the point. And this is what our commands look like. So before I move on from this, any questions about what I've talked about so far? Okay. So as part of building these pipelines, we went through several iterations of the code behind this. We started off with GenFSM. How many people here have used GenFSM? How many people like using GenFSM? Oh, one guy. We had a GenFSM that started at something like 300 lines of code, and by the time we were like, yeah, we really need to refactor this sucker, we were up to almost 3,000 lines. It got really hairy really quickly. And so what we wound up using was GenStage, and I know there's already been another talk on it, so I'm not going to belabor the point too much. I will talk a little bit about it. GenStage is awesome. If you're building something that looks like a processing pipeline with like discrete stages, and you need to wire those stages together, it's really, really nice. So what is GenStage? It's an experimental OTP behavior for building pipelines, and we'll take a look at it in a second. It's got the notion of producers and consumers, subscribers. It has multiple flow control strategies, which is really nice. So you can do things like streaming between two stages, or you can do batch. And it does streaming by default, which I don't know if anyone's ever tried to implement this kind of thing on their own. Like I've built this kind of code a couple of times, and it's always really fiddly to get right. Because handling flow control tends to get a little racy at times and is hard to coordinate. So the fact that we have a behavior like this that does all that for you and does it well, really nice. So applying GenStage to command pipelines. Wow, this stage. As I try not to step. So you've got 3 commands here, foo, bar, and baz, and I want to pipe output from one to the other to the final one. Each one of these commands can generate arbitrary amount of output. So the way we modeled it was to say, okay, here's what the user typed in, and then we would add these implied nodes begin and end. Begin was responsible for initiating the pipeline, and end was responsible for gathering everything up and sending it back to the user. So applying templates to the output and making it look nice, doing any kind of error reporting, that kind of thing. So in GenStage terminology, begin and end were pure producers and consumers. And everything in the middle was a producer and a consumer. And we were able to use GenStage's flow control strategies to handle getting the data from one stage to another without having to write any code on our part. So every time a user typed in one of these pipelines, we would have a whole chain of GenStage processes stitched together and executing, all supervised. It's really nice. So let me conclude. I'd actually built more time in to do a demo, but like I said, oh, are you kidding me? The network gods really don't like me. Hold on one second. Boop, boop, boop. Haha. Here we go. So this is a screencast we did to demonstrate what it was like to work with one of these commands. And we're not going to sit here and go through the whole thing because that would just be like violating the Geneva Conventions a little bit. But I'll highlight a few things here. So like a lot of bots, this is how you get its attention. You prefix any command you want to run with a bang. And so you can type like help, CFN, and you get all this nice output about the command. So really similar to like your Unix command experience, with this being more like a man page. Let's skip forward here a little bit. Okay. So the command had this notion of having stacks. So if you didn't have any stacks yet created, you could build one from templates. You can list all the templates. And yeah, here we go. And so then you can use the stack create command to once you know the name of the stack and the parameters you want to pass to your template, you can create it there, which I think will happen here in just a moment. Yep. So it gets created and tells you what all the parameters were. And then hopefully here we show, yeah, so this is piped through. We had a templating engine that would generate all these nice templates regardless of what chat provider you were using. So we tried to make the output look the same across everything. But yeah, so that's kind of what it looked like in practice. And that's it. Any questions? Cool. Thank you. Oh, yeah.
So say more on half of your company.
We were founded in 2015. We got a nice seed round, and we built all this out. We had several companies using our stuff. So we had a team at Oracle, and we had an ops team at Kickstarter using our stuff. And we had maybe around, I'd say somewhere between 50 and 100 installs in our open source community. And so we were going for our next round of funding after a couple years of working on this, and just weren't able to quite close the deal. So all of this stuff I've showed you is open source. We did all of our work as Apache 2 licensed code, and this is all available up on GitHub. But unfortunately, we were unable to get more funding, so we wound up having to wind down actually at the beginning of the month. So that's kind of the current state. Thank you.